So this talk is called DDoS as a Service, using JMeter, Docker, and AWS to load test your application. A bit about myself. That's me on the right side, enjoying a beer in Berlin. I'm originally from Aruba, island of Aruba. This is the flag of Aruba, in case you've never seen it. I've been working over 3 years at Luminis. Oh, by the way, I just figured out how animations work in Keynote, so be ready for a lot of unnecessary animations, that being the first. This is my second time speaking at the DevCon. Last year I gave a talk about GraphQL, and this time something a bit different. And at Luminis I do a lot of stuff, Java and code, program stuff, but also load testing, which is what I'm going to talk about today. These are the contents. I'll give you a bit of time to read them, let it sink in. It's just me asking you to hold your questions till the end, because we have a lot of things to get through. So what is DDoS? DDoS, that stands for Distributed Denial of Service, and DDoS is a type of attack that an attacker can do on a system with the attempt to, with a goal to decrease how the system will react to a normal user call request. So how this is typically done is something like this. So you have at the top an attacker, and it uses different devices to send a large load to a system with the goal to try to make the system non-responsive. So either decreasing the service or completely denying the service. So that's a DOS attack, and distributed is just the same, but then over multiple devices. Either the attacker has this many laptops, or they have somehow got control of it in one way or another. So that's a DDoS. That's what DDoS means. But I need to say that this is not a security talk. So no security. Second animation. The reason I call this talk DDoS as a service is because when I was performing the load test, this is what happened to the system under test. And this is what happened to my laptop. What I'm trying to say is that while performing the load test, we broke the system a few times and also managed to break some laptops a few times, which is why I'm going to explain today also how to do this correctly. And you can learn from my mistakes. So what is load testing? Load testing is you're testing your system by sending a load to it to try to see if the system responds in the way that you expect. Does it still perform with the correct speed, latency, or will it break under certain stress? So this is what a load test looks like, just like the attack, except there's a more friendlier face at the top that doesn't want to do you any harm. It just wants to try and see what the limits are of the system. So a bit of semantics, load testing or stress testing. Saw these two definitions online. Load testing is you want to test how does your system perform at a given load. So you want to know if the performance decreases, stuff like that. And stress testing is how much load does it take before the system breaks, whatever that might mean. For this talk, we'll just take both of these things and just put it under load testing. So we're interested in just what is what happens when we perform a certain load to our application. So how does a load testing flow work? Well, this is a very simple high overview of how that works. Is you establish acceptance criteria. For example, I want to be able to, with 100 concurrent users, the request should still take 100 milliseconds. That's very concrete. And you would create a test that would simulate 100 concurrent users, so 100 users sending API calls once per second, for example, and see if you get a response for within 100 milliseconds. You analyze the results, and if you're happy with it, then that's okay. If you're not, if something goes wrong, then you're going to figure out where the bottleneck is, and you'll try to fix the problem. So this will continue on until you're happy with the results. If you do reach your criteria, then you should start having talks about, okay, are we happy with this load? What does it mean for our system in the future? And do we need to test bigger loads? And that's how it keeps on going until you're happy with the system. So why do you want to load test? Well, that's where I created this part in this talk called Tales of a Load Tester, where I'm going to try to scare you guys into believing that this is a good idea, that you need to do this. So, Oh, that's too bad. You guys missed the ghost. Wait. No, it's worth it. We'll wait. Ooh, okay. So, first tale, safety in numbers. I call this safety in numbers. You'll see why in a bit. First system is very simple. We have a system under test, which is just a backend system. We have some kind of network component in the middle, which in our case was hosted by another party. It wasn't, we weren't in control of it, but the only thing that it did was route messages to the system under test. It did some load balancing, stuff like that. And we have our application that makes use of this system. And you can see that the two components on the right side, they're inside of an acceptance environment, which gives you the hope that if we were to do a load test on the acceptance environment, which you see on the left there, we used our load testing tool to simulate the mobile application that would talk to the network component, and we sent, for example, 100 requests per second to the network component, and we would get responses back. And the idea is of acceptance and production environments is if something were to happen, for example, this breaks, you would still on production environment have happy users. Except that wasn't the case because turns out that because the application was still being developed and we didn't have a lot of users on production yet, the same network component was being used for acceptance and production, which means that we got a lot of calls when we started performing our first load test of why can't we use the production environment anymore. Well, this is the reason why. Luckily, this was at a very early stage of the application, of the system, so we didn't have that many users yet that had issues, and luckily, because of load testing, we were able to fix this on time. So that's, oh yeah, they weren't very happy about it. Second tale is called an arm and a leg. So system under test again, and it is simply just a backend application that connects to IoT devices. So multiple IoT devices, looks like a wash machine, but it doesn't really matter what it is. And the way they connect with each other is they have TLS encrypted messages between each other. So they're encrypted, they have a session on both sides, and they can communicate with each other. And we did a load test. So instead of the IoT device on the right, we created, again, using our load testing tool, we tested our system under test a number of times. And what we saw was that the test went completely fine. We were happy with the results, except the DevOps guy that looks at these kinds of graphs on a daily basis realized that all of a sudden the memory, the heap usage was dramatically high, and it didn't go back down after the test. So even if it did go high and then go back down, you could accept that. But it didn't go back down until we restarted the entire server. The reason was that it turns out that in our system under test, that each TLS session cost a fixed number of megabytes. So, and they can't be garbage collected because you want to keep these sessions in memory so that you can easily use the session to communicate. It would be very inefficient to every time when you want to send a message to do a new TLS handshake to communicate. So this is something that didn't initially, we didn't see this as an error in our test, but because of monitoring, we were able to see this, and we could use this information to predict how much memory we will need in the future given a number of IoT devices. So this is very useful information to have, and this is something that you can figure out very early when a system is already running. Third tale, same system again, but now with some more information. So the TLS messages, they are going inside a WebSocket connection. So there's a WebSocket connection between the IoT devices and the system under test, and they're all connected to one port, which is hosting the WebSocket server. And we did this. We were testing using a load testing tool to test a number of IoT devices. We started at 10,000, 25,000, 50,000. Everything was good, 0% errors. And then we tested 75,000, and we realized that we had around 17% errors all of a sudden. So 17% of errors, and those errors were that the connections weren't being made. The reason for this is that it's apparently only 64,000 open TCP connections can be open at the same time on one port. This is something that we didn't take into account, and the solution was easy. We opened a new port and we added a load balancer. But the important part here is that we were very early in detecting this because we did load testing. We were in production, I think 25,000. We were already testing 75,000, and that's because of that we figured out this, and we were able to fix it on time. So a few more issues. So the 3 things that I mentioned there actually have absolutely nothing to do with the system under test, but just the things around the system under test. So you could be programming the best application ever, but you could still have issues, and load testing can help you with that. Some more issues, for example, like your server not having enough memory or CPU, or memory leaks, problems with handling of queues, and the length of queues and things blocking. U-limit, so the number of open file descriptors for TCP connections, maybe you forgot to set it a bit higher so that you can reach the number of connections that you need. Deadlocks, and more, much more. So that's why you should do load testing. How can we do load testing? Well, first of all, you need a load testing tool. You have a few of those. Here are some icons. The most, I think, most popular one is Gatling. But you also have a few other shown here. Today, I'm not going to be showing any of those. I'm going to be showing JMeter. The reason for this is because at Luminis, we have a lot of knowledge about JMeter, and that's basically the reason why. I'm going to be giving a small live demo right now about how it looks like. So I'm going to sit down. I'm going to ask you to please hold your applause until the end of the demo. So, switching over to JMeter. I hope this is, I think this looks okay. This is Apache JMeter, and this is what it looks like when you just open up JMeter for the first time. I'm using right now version 5.1. And over here, you can see the tree. Well, the tree is not that big yet, but it contains a test plan. And this is what we're going to build on to create our testing script to send to a server. So first thing you want to do in JMeter is always add a thread group. So you're going to at least want to start one thread or multiple threads of to run whatever script you're going to define inside this test. So as soon as I create this, we can see here that we have some configuration things you can choose. I'm not going to go through all of them. Basically, I'm just going to show you the bare minimum you need to run this. So you can give it a name, but I'm just going to leave it like this. I'm only going to talk about these 3 right now. So this is the number of threads or users or clients, whatever you want to call them, that you want to simulate. For now, leave it at 1. The ramp-up period is a number of seconds it takes to start up this user. So if I would start 1,000 threads, then here 10, then it will distribute the starting of these threads over 10 seconds. But for now, we're just going to leave it easy. Just start one thread, take 1 second to open it. And here you could also loop forever if you want, or loop 1. And what it loops through is whatever we're going to define in here, in this thread group. And I think the most simplest thing we can do is do an HTTP request. So you can add sampler. You get a lot of things, but we're going to add a sampler. And you can see here a lot of options. For now, just the HTTP request. And again, a lot of things to click through. Just going to do the bare minimum, and that is here we can add the protocol. You can choose HTTP or HTTPS. For now, simply HTTP. I'm going to be running it to localhost, port number 5000. Here you can choose your methods, your HTTP methods. Get is okay for now, and I'm just going to do it on the index path, so no path yet. And I'm going to add one more thing, and that is something that's going to show us the results of our test. So going here to listeners, I'm going to add a results tree, which will show us here all the samples that we run, and if they were successful or not, and why they weren't successful or not. So if I were to run this right now by playing this, pressing on this button, we can see that it's going to tell me first I need to save the plan. Yeah, that's true. So I'll give it a name. Live demo, and now we'll run it, and we'll see, it's connection refused, and that's to be expected because I'm not running my local server yet. So let's do that first. I'm switching over to Visual Studio Code. I have here a lot of stuff. Only thing we need to look at right now is the local server project and just the index.js. Simple node server, a lot of code. Only thing you need to know is this is a package to create a web server, and I have here 3 endpoints defined. Only care about this one right now, which basically when it gets a request, it just logs got a simple request and sends back this is a simple this is a response. And here you can see it's listening on port 5000. So if I navigate to local server, index, and now it's listening. So if you were to do the same thing again, we can see now that it's okay. It took 13 seconds to get a response. You can see a lot of information here about it. The status code, response message. Here we can see the request, the outgoing request with its headers, and the response data. This is the response. So very simple now. Just to recap, test plan, thread group with one thread, HTTP request, and something to show us the results. So what we can do now is also, we don't want to send just one request, but maybe we want to send a number of requests. So you can add a loop controller here, logic controllers. We have a lot of them, if, while, loop. I'm just going to use, for now, keep it simple, a loop controller. And very important to put whatever you want to loop to make sure that it's inside the loop controller. And here I can add a number, so I can add any kind of number I want. I'm going to add 10 for now. And this is the button to clear all the results. So I'm going to clear it. And if I play, you'll see 10 requests. They went pretty fast, but it's 10 requests after each other. And we have already sent a load of 10 requests after each other. Of course, this is still just one thread group, so it's doing it sequentially after each other. We can see that by also adding a timer. So we can add a timer here, which will add actually a delay. And I'm going to make it send the message once every second. And we can see that, that it's sending it sequentially and not in parallel. So it's sending every second now a request, and we can check on our server, it's still getting the request. So, so that's nice that we have that now, but what we also might want to do is run more parallel users next to each other. That's a common use case. So for now, let's increase this to 10, and we can see that, as you expect, it's going to be all over the place. It's sending a lot, so it should send about 100. And when you this is kind of hard to read all of them one by one, so you can also add another listener, which is the summary report, which I'm going to put here. I need to run it again. But this will give us a summary of our test. And very important is to see here that we have no errors. So that means that everything was okay, and this should reach 100. And then we've completed our test. Right. So up to now, we've been sending everything to the first, the very simple path. I also have two more endpoints. This one is called delayed resource, where we can, in the path, we can add a delay to sort of simulate a real application that sometimes takes a bit more to respond. So by adding, for example, I don't know, 500 milliseconds here, take notice that here we can see the latency, and we were going to see this increase now as we run. And it's going to be very different numbers, I expected. Oh, it's only going to be 500 instead of a very low number. And you can see here, this is the request being sent right now. To even simulate it a bit further, we can add a randomizer to add random numbers. So config element, random variable. I'm going to put it over here. And you can give the variable a name, and from this point on, you can use this variable anywhere in the rest of the script. So I'm going to call it delay. Minimum value of 100 milliseconds to 1 second. And I can use it here. This is how you do it in JMeter. You can access parameters. And if we run it now, we should see something that's behaving a bit differently. I expected more different numbers, but it's a chance thing. So here, 900, for example. So we can see that now we're running something differently. And now I talked about those acceptance criteria. In this HTTP request, I can go here to advanced, and I can add here a timeout. So we will see errors when it's not fast enough. So let's say if I have a criteria that everything should take 800 milliseconds at the most, and we know that our system now sometimes will send a delay higher than 800, then we should start seeing some errors. So let's see how that works. See, we already have a few errors. This one is indeed above 800, but these ones are below 800. And we can also check our summary report. And if we check what the error exactly is, then we can see that timeout, read timed out. And that's correct, because it took longer than our timeout that we set up. So this is a way, very simply now, that we set up a test to send a load, we set up our acceptance criteria, and we can see how much percentage we have that actually is within our acceptance criteria. So one last endpoint before we go on with the demo is also the super secure delayed resource. And what that does is it checks if you have a header, any type of header that has the name authorization. And if not, it will send a 401 back, so you're not authorized to do this call. So doing that, we can see that if I just run it now, that we will only get errors, of course, because we don't have a token. Unauthorized, that's correct. So what we're going to do is we could also add headers. So config element, header, you can add it here, authorization, and just a token, 234. And that's it. That's how you add headers. So if you want to add any other headers, you can do it like that. Play again, and it works. And some of them don't, but that's because it's 800. Now, as your script gets bigger, you probably want to have one place where you add all your variables instead of adding them all inline here. So what you can do is at the top you can add an environment variable component, and here we can just add whatever variable we want. So we can say token and 4, and we can access it here. So we can do the same thing for every other variable. Not going to do that right now. One more thing. This now will only send one token every time. So we have here every time the same token. We could also, for example, if let's say you have generated some tokens somewhere because you want to simulate multiple users and not just the same user sending things all over the same time, you can create a CSV file, which I did here, which basically just has an index and then a UUID for now, which is not really a valid token in web development, but for now this is okay. And we can read this file by adding the CSV dataset config, and we can find the file we want to use, tokens. We can leave the rest as it is. I've never touched any of these things. So here you can add the variable names with a comma to delimit them. So the first one I'll call the ID, the next one I'll call token. I gotta make sure to remove this one then, because otherwise it will clash. I think we'll just override it anyway. And now we have token here, so we already set it up. So we should see that it's using different tokens now. And we can check the headers, and we can see 5, and it changes. So this is a way that you could test different users, or if you want to get anything else out of a CSV file, you can do it like this. Very important now thing about JMeter is you design your test inside of the JMeter console, but you never actually run it in JMeter itself. You always run it in the command line because it uses then less resources. I have a completed version here. This is the live demo version. I hope I haven't forgotten anything. Looks the same, except I have a lot more environment variables now. Just going to quickly go through them. This annotation means, okay, if I give, you can give these parameters via the command line. If you don't get it, then use the default of 10. Use the default of 1000. This one is just a number of requests per client. The delay per request, the default of 1 second. The number of clients, that's the number of threads I want to start. The ramp up period, default 2. The timeout, which I put at 2000 now just to get a lot of success responses. The host, which will default to local host, the port, and the resource path. So that's the path I want to call, and the CSV file. And the rest should look the same. A loop with a random variable, delay, HTTP, and HTTP header. I have also here a an actual listener, but it's not important. So if we now go to my project, I'm going to close this. And now I've created a shell script to run JMeter because I don't want to type that all out. And how that looks like is this. You can call the JMeter command. And close this. And these are the variables you give. The T is the test script. So this is the completed text.jmx that I just opened. You can tell them where to put the log files. That's just the output of JMeter. The XML files, those are the sampler dates. For every sample, it creates a sample element in XML, and you can find the latency and everything you want to know about every sample inside this XML file. With the prefix of this capital J, and then the name of the variable. This is how you give parameters into JMeter. So this, I'm telling him here, this is the where the token is. These are three things that tell JMeter how I want to format my output. So XML, I want to have all the response data and also the sampler data. And this is the variables that I've shown before. So I'm going to have request per client 10. Every second, one client for now, a ramp-up period of 1. I'm going to be sending this to Amazon, so I have a server running somewhere in the cloud. Also has a super secure delayed resource and with port 443. I'm going to show that now, how that works, how that looks like. So going to JMeter. And this should be okay. Just to show you how that looks like in JMeter. So you can see it already created the log file. And in a bit, when it starts sending samples, it will also create a test XML file, which later, these XML files, you can also import it into JMeter to see how it looks like. JMeter will create this summarizer, which will, in a bit, tell you how much percentage of errors you have within every interval. And I think the default interval is 30 seconds. But since our test only takes 10 seconds, it will only need one line of the summary. So in this line, we can see that it did 10 actions and it had 0% errors, also some information about the latency and the average latency. And that's it, that's the end of the run. And yeah, that's basically in a nutshell how JMeter works. You can do a lot of more things with JMeter, but this is the basics we need for now. So I'm going to go back to the presentation. Also, I mentioned WebSockets in the first part. If you want to use WebSockets, a colleague of mine created a JMeter WebSocket sampler. If you want to use that, you can check, if you Google JMeter WebSocket sampler and then Peter, and you'll find it. And you can use that to also test WebSocket connections. So not only HTTP requests, but also WebSocket connections. That's the end. Except that it's not the end, because if you want to do this on higher load, it's going to crash your computer. You're going to run into problems like CPU, memory, native threads not being able to start up. Also portability, if you want to run the same test on someone else's laptop, probably, oh, I don't have the right version of JMeter or whatever. And also your network could be a bottleneck. So I've ran the same test I've normally run at home, and I got like 90% errors, and if you run that somewhere else, you probably maybe get 0% errors, I don't know. So that could also be a factor in your test. So this is what we want to do, but you noticed already the difference between my setup and this is there's multiple, besides that he's smiling, is that there's multiple devices there. And I don't have that many laptops to run performance tests, so I need help with that. So I'm going to be using Amazon ECS, that's Elastic Container Service, to provide me with a lot of computing power to run these tests. So the same test script running on multiple devices, all to one system. To do that, to run on multiple devices and still have the same result, we're going to make use of Docker. So Docker is going to help us to make sure that on all of these devices we're running the same system. So what I've shown so far is this. It's just locally on my PC, JMeter talking to a system under test. And now we're going to use the power of the cloud. I'm going to push the system under test in the cloud. And with the help of Amazon and Docker, we're going to be running the JMeter script inside there and sending the load to the cloud. So Docker in a nutshell, because I'm not going to talk too much about Docker. I think these days most people know in concept what it is, but Docker helps you to run your system in a contained environment. So you define in a Docker file, I want to have this operating system, download this version of whatever software you need, put these environment variables there and run this action, run this command. So that's it in a bit, and I'm going to show how that works. But first, also with Amazon ECS. So with Docker, we define, okay, this is how you run it on one device. And with Elastic, with Amazon ECS, we're going to configure it to run on multiple devices. So 3 things you need to know about Amazon, or 3 terms. Those are the repository. That's the Docker repository containing the images. So I'm going to create a Docker image which contains the test I just showed you, the JMeter test. And then I'm going to define a task which tells Amazon how I want to run this Docker container. And finally, we have clusters where you can start multiple instances of those devices where I want to run my tests on. So 3 components. And it's going to look something like this. So we have a repository on the left with the Docker image. The task is pointing to it, saying, okay, this is the Docker image I'm going to run. And the EC2 instances that I start inside of a cluster will use this task to know which Docker image they need to run. So again, a demo I'm going to run right now. So this one's not going to be live because when I did the rehearsal test for this presentation, I made a few mistakes, so I made some videos. I hope you can read this. This is the same Visual Studio Code that I showed in a bit, and this is the Docker file. And what you can see, I need to think I'm going to sit for this. And what you can see is the Docker commands I'm giving here. So first of all, I just want to get an Alpine distribution with OpenJDK 8 already installed on it. Some basic things to install packages and get wget, which I'm going to use to get JMeter. And some environment variables. You might recognize these environment variables, which in a bit at the bottom you will see that you can add environment variables here and they will be passed on to JMeter. And from Amazon we can also override these variables, so you can be in complete control of how you want to run this test, and basically just by changing a few parameters you can very quickly run different variations of your test. So I'll play this. So you can see a Docker file there. And scrolling down, so here I'm getting JMeter. I'm copying the test file and the CSV file, and you can see here running the JMeter command with -n, which is non-GUI, and the same things that we've seen before, except using the environment variables from the top. Moving on. So this first step, what we want to do is upload this Docker file into Amazon repository, ECS repository. So I'm going to click on a repository. And here I already have 2, but we can create a new one. I'm going to call it video demo. And I made some mistakes on purpose, so it feels like a real demo. Just going to wait. Okay, so now we can see that it's there. And if you click on it, you can see that we have no images yet. But if we click here, it's very handy. Amazon will just give you 4 commands that you need to do it. So we can just copy it, go to the command line. Now I have to navigate to where it is. I didn't want to do the video one more time. Just left it like this. Navigate to demo, and the first thing is I need to log into Amazon. So just pause it here. So I'm now using the Amazon AWS command line tool. And this is the first command that it gives you to log into Amazon via the command line. And you can also add multiple profiles. For this demo, I have a profile called DevCon. So I need to add it as an extra parameter here. And it will tell me, okay, that's fine, you're logged in now. So you're authorized to push things to the repository. So then comes the building of the Docker image, which will do it based on, you can see here the dot build. I'm going to tag it with the name video demo, and this just means look for the Docker file here in this directory, and it's going to run through the steps of creating the Docker image. So a Docker image is basically just imagine if you bought a new PC and you installed some things on it and you turn off your PC, when you open it again, you still have all those things on it. It's the same thing here. You're downloading stuff. You have an image. Whenever you start it up, you have all these things in it. So we have this image ready. Now it's tagging it again for Amazon, and then the last thing you do is you push it to the repository, and this is also an advantage of videos. We can just fast forward it here, save everyone some time, and we can see that if we switch now, we still don't have any images, but if we refresh, then there we have our first image. So this is the first part, is creating the Docker image, which has our test in it, and pushing it to Amazon. So moving on, now we're going to create our task definition, which is the second of the three things that we should know and we should use. Going to task definition, I'm going to pause it here for a bit. When you create a task definition, you have two options. You can use Fargate, which it says here is an Amazon AWS managed infrastructure. And what that means is you simply tell Amazon, I have a task and it uses this much memory, and you have to figure out how many instances you want to start to run it. In EC2 launch type, you as the user have to say, okay, start 5 instances for me, and then run the task on those instances. For this demo, I'm going to use EC2, even though this sounds very ideal for performance tests, load tests, except I couldn't get it to work in time for this demo. All I got was that it started off JMeter, and then it didn't want to send any messages, outgoing messages to my system under test. So if anyone knows why that is, please let me know. But for now, we're going to use EC2, which means that I will need to scale the instances myself. So I need to tell Amazon, start 5 of these types of instances. Again, same thing as JMeter here. I'm only going to show the things that I know what they do, and the rest you really don't need to know. There are a lot of things you can click here if you want to, for example, run an entire web service on Amazon. But for the use case of load testing, you really only need a few things. We are just interested in the compute power. So here I call it video demo. We don't care about, this is important that you choose bridge if you're using Linux. The task memory, that's just something I know out of experience that my test, if I run 4 gigabyte, then it's going to be okay. Oh no, that's not good. Let's go back. Sorry, I misclicked here. One way to figure out how much memory you need is just to choose a number. You start to run it, and then afterwards you can check out how much memory your test used, and based on that you can configure it and get a better number each time. So here you're going to get the container. So the container that the image that we previously uploaded, you're going to get the identifier here by copying it. So you need to tell this task definition which container you need to use. Here you can add anything you want. We're going to add the same limit as we did at the top. And basically you can leave the rest, a lot of interesting things here, but we don't need any of them for load testing. Except the environment variables, which also very glad that we can skip all of this. So I'm just entering what we had now. And wait, yeah, that's it. So I've added all the environment variables that I want to call Docker with. And then finally also logging is important. And these days, if you just click on this, you will automatically get all of these things set up for you. It's going to send it to another Amazon service called CloudWatch, which every time you run this task, all the logs will be sent to Amazon CloudWatch, which we'll see in a bit. That's it for the container definition. You can leave the rest as it is, click on create, and we have our new task. So if you go look at the task definition list, it will show up there as a task that we can use. So that was the second of the 3 things we need to run our load test in Amazon. Moving on to the third, which is the cluster. We need to create our cluster. So clicking here, and we have 3. Oh no. Let's try that again. So you have 3 options. The first one is basically just Fargate. So if you're not going to use Fargate, don't use that one because you're going to get errors that they're not compatible. Since we're using EC2 launch type, we only have 2 options, EC2 and Linux or EC2 and Windows. So basically you have 1 option. Oh no. I'm just going to fast forward. So I'm just going to choose EC2 and Linux. Here you can just give it whatever name you want again, just remember it. And here you also have a weird option about the provisioning model. So you can either pay for the compute capacity by the hour, or you can use something called spot, where you bid for instances. However, I don't have any information about that. So this, very important, the EC2 instance type. This is where you choose the type you want to use for your test. So every instance type has a different size of memory that it can use and CPU. So you can look online at EC2 pricing. If you Google EC2 instances pricing, you will see all the instances that you have and how much it costs per hour. For this test, the default M5 large instance is good enough. You can choose here how many instances you want to start off at right now at the moment. So 1 is okay. Don't touch the rest of these things. One important thing that you might want to use in case you run web services is you can also create a key pair so you can SSH to the instance. But since we're running load tests and it's only temporary, yeah, I'm not going to do that. About networking, you have these things called virtual private clouds. Don't think too much about it, just create one and just use the defaults. I've never had any problems thinking about which virtual private cloud I need to use. So you saw there an option to create one, but I already did, so I'm just going to choose the ones that I always use. Security group is something where you can edit it to the inbound and outbound rules. You can change them, so which ports and which kind of messages you want to get. But I've also left the default because that's fine enough. We don't have any incoming calls, only a lot of outgoing. And that's it. You click on create, and it's going to create that cluster for you, and it's also going to start the first instance for you. So a virtual machine is getting started with that instance type that we defined. So also here we can fast forward. And we have our cluster, the video demo cluster. If we go to instances, it takes some time for the instances to start. So if you fast forward, and I'm clicking a lot of times on refresh, continue here, we can see, can see that we have an instance there. If we click on it, we will go to another Amazon service called EC2. And this is where you can really see a lot of information about that instance, about security groups and a lot of things. But yeah, it's only going to run for a while, and then it's going to do our tests, and then it's going to close again. Sorry, I said it incorrectly. The instance will keep running, but we are not interested in all of these things, like for example the IP, we're not going to be connecting to it. But if you were interested, this is where you find that information. Things like monitoring, you can also see how much utilization of a lot of things you can see there. And so those were the 3 things we set up. Now we're going to actually run the test in Amazon. So we can go to our cluster, we click on task, and we click on run new task. We click on the launch type we want. We can click here the task definition and the cluster we want to run it on. So everything we set up comes together right here. We just want to run one task at the moment. And all the way at the bottom here, so skipping all of these, all the way at the bottom here, we have the option to add overrides. So let's say the first time I want to run it with a delay of 100, the second time I want to run it with 1000, or maybe I want to add more clients. We just add it here. And when we click play, it's going to run the same JMeter task in a Docker container on the EC2 instance, but then with these parameters. So this is how you would then, if you're happy with the results, you could increase the load very easily and test your system multiple times since you have everything set up. So we can see here in task that now we have a task running. Remember that we set up CloudWatch, or it was set up for us, so we can actually go into CloudWatch now, and we can see the logging that it shows. So this is CloudWatch, another Amazon service. And we can see here that the log group was created for us, the ECS video demo. And if we click on it, we can see The same thing we saw when I ran it locally, except that it's now 2 lines. So first it ran 7, and then it ran 3 items, 0% errors, 10 items in total. So that's good. And we can also scroll to the bottom, and we can see also the test log, complete test logs that it shows. And also this is what the XML looks like, but since we have no errors, I'm not interested in that right now. Of course, one test, that is not really a big load. So now we're going to run 5 instances, all of them running 1,000 connections at a time, 1,000 requests at a time, for a total of 5,000 messages to my system. So here we go. You can see already that we have 5 instances there. Clicking on it, you can see that I've already scaled 5 instances where we're going to run our system. You can see the CPU and memory available. Here, let me go back, went a bit fast. You can click on this. If you wanted more instances, simply just clicking here and adding a higher number, and the instances will get started. So now, instead of running the task here, I also want to show how you can run tasks in the command line, in case you want to do that in your CI/CD or stuff like that. So first off, I have a shell script. The number of instances I will be sending here. So the number of instances that I have running where I want to run my tests, I will give it to the script. And everything else I have defined here. So the cluster name, the region of Amazon, the task name which we defined, and we also have an overrides JSON file. And I'll show that in a bit, how that looks like. And that's just the environment variables which I showed that I override in the first one. We can also override it via just a JSON file. So clicking here, we can see the delay per request, number of clients. You can add anything here. You can change it here how you want. And then when we run the test, we will be running the same thing we did via the console, via the web console, but then via command line. So should be running the test now. Yeah, that's good enough. So running the test, it will print out this JSON with the results of the test. So basically, I'm not going to go through all of it, but it just shows you which task with which environment variables were run. And if we switch over to Amazon, we can also see that we have 5 tasks currently running, which also means that if we switch over to CloudWatch, we will also have 5 new log streams to look at. Need to think about it. And then looking at the first, so now we have 5 more instead of just the first one. Clicking on it, and we can see now it's still looking okay. 86 requests already sent. But when we refresh it, which we'll do in a bit, and again, maybe I should fast forward. Okay, pause this a bit. We can see that we have now, for the first time, errors. We have 14% errors, which is interesting. And just to make sure, we'll check just one more container to see if they also experience errors, and they have 20% errors. Of course, if you add more containers, you don't want to be clicking one by one in these things. So Amazon CloudWatch also has the ability to query for specific things inside your logs over multiple log streams. And I'll show that now. So important, this is the log file I want to use. So the summary of 10,000 items, I want to be able to see for all containers how much percentage I have, just to get a feel for how well the test went. So if I go to Amazon Insights, I can choose the log group I want, which is the video demo. And I already have some of these queries I want to run written somewhere. All of this is documented in Amazon, but I have to admit that this was pretty hard to figure out. So it was a lot of playing around with these things because there are not a lot of good examples online. But this is one that works for this combination of JMeter and test. So just to see what happens here, this is what the syntax looks like. So we have the fields that we want to be returned. So the log stream and the error percentage. So for each log stream, I want to see the error percentage. Out of all of our messages, we want to filter out the messages that have this text in it and also have the text 10,000. So then it's going to filter out, so we're only going to be left with those messages. From those messages, I want to parse this pattern here, so I'm going to look for the pattern that starts with this. And these two stars, I'm going to put them in this variable. The error count, that's okay, but the error percentage I'm interested in, so that's what I'm going to be returning. And you can sort them by log stream if you want. Just to show here, the log stream is the identifier of the log stream you can find here. So looking at the video demo, you can see these are the log streams identifiers. So if we run this, one more thing, you can also choose the date it's going to run. I mean, for the amount of time that you want it to look. So I think the last 15 minutes should be okay, since we just ran it. So if you take that and we run the query, we will get a response of surprisingly 6 items. However, sometimes with this mode, as I mentioned, the summary, the JMeter summarizer, it prints out the percentage every 30 seconds. So if you have a bit of a bad luck, then it will print it out 2 times, 1 time for the increment and 1 time for the final print. So you can see this one logged it twice, but it's clear that we have errors. That's a problem right now. So now we're interested to know, okay, what are the errors? Because now we want to know what's going on, why it's going wrong. So we can also use insights to query the error type distribution. So see, we have 10 minutes left. So see if this is the right one. Yeah. So now I want to show the error and the error count, and filtering. This is for the samples of the XML samples have this parameter S, which means success. So if it wasn't successful, parse the response message here. I want to count the number of errors and group them by the type of error, and then sort them based on the type of error that had the most, that showed up the most. And when I run that, I see that I only have internal server errors. So when you have internal server errors, then it's time to go look at what's happening on the server. So I'm going to do just that. So just to show here that we actually did get 50,000 API calls. This is on the Amazon API gateway. So when I said I put my my system under test in the cloud, this is the API gateway where it runs. And we can see here 50,000. But we also have a log group for this, and if I click on it, and I'm not going to go through all of them, I know that if I put here error, I will get it, and it shows rate exceeded, and that makes sense because for my API gateway, I have a rate limit. And basically, what I've just shown is how you would run one test, how you diagnose the problem. In this case, you have to decide, okay, am I happy with this rate limit, or do I want to increase it, or stuff like that. You fix it, you run it again, you go through all of that until you're happy. A bit about pricing. So this is not free. The instance I use now is, I think, the M5 large, and that's costs $0.115 per hour, dollars. And data transfer is, incoming data is free, outgoing data is $0.09 per gigabyte. However, I haven't paid anything yet for data transfer, so you have to be sending a lot of data in order to have to pay that first price. This is still relatively cheap compared to things like JMeter, where you have to pay a monthly subscription. So this is, you set it up once and you know how it works, and you only use it at the moments that you want to run your load test. So you don't have to pay a monthly subscription for that. Takeaways for this presentation. I hope that even if you don't like JMeter or Amazon, you want to do everything on Azure, that's fine. But I hope that at least you get the idea that you should start load testing if you don't do it already. Tell your project manager or scrum master that this needs to be an item on the backlog, because you can find really unexpected issues in your system. And it also gives you a peace of mind, and for you and your clients, to know that your system can handle this load. There are many tools available today, only shown JMeter, but there's a lot of things to play around with. And Docker and cloud works really well together if you want to do larger scale tests. And also, yeah, have the correct logging. So JMeter has logging, but also make sure that on your server you have logging. And if you can monitor things, network between components, that's even better. So you can diagnose where the bottleneck is and fix the problem. Don't forget to vote in the DevCon app. You can vote for the talk. And that's it. That was the presentation. Thank you. Are there any questions? Yes.
We went through a lot of configuration. Do you always need to do that for test scenarios?
It depends because if you create the same, it depends on what you want, what you mean by test scenario.
I'm guessing you can have multiple test scenarios for DMX, right?
Yeah.
But what if I wanted to add another one, like a fourth scenario? Would I have to go through all that configuration again? Is there a way to streamline it into my...
The question is if I want to, let's say now I have one HTTP request, but if you wanted to add more, is that what you meant? Yeah, by scenario, you only have to update the Docker image. So you don't have to create the task or the cluster again, because it will run that image. And because it's in your JMX file, it will just run that inside of your loop, your thread group. So we'll just run all 4 of them. So just upload the new version. The task definition will always use the latest version of your Docker, so you don't even have to update that. So it just goes automatically. Any other questions? Yes?
Is there a risk of Amazon flagging you for DDoS?
I don't know. We've tested really big loads, like 100,000 WebSocket connections to it, and we haven't had any problems yet. So I can't say for sure. Maybe if we do 1 million, then we'll get problems, but then we'll just create a new account. So yeah. Any other questions? Yes? Yeah, so for a Mac, if you do more than 2100 threads, so you saw the thread group I created, if you do 2100 or something like that, then we got problems. And we either got 2 things, either it didn't crash and it said could not create more native threads, or it wasn't responding anymore. So one of those 2 things. So it's around 2100. I know for Linux it's a bit more, and for Windows it doesn't have that native thread. It will just crash at some point depending on the device. So yeah, no, I don't know. My laptop didn't do anything anymore, so I needed to hold the button in and restart the laptop. So I don't know what was going on, but it happened. So, but it's at if you do that much. So that's why we first started just doing more laptops next to each other, but that's not scalable. So we needed to move to the cloud. Yeah. Any more questions? All right. Thanks, everyone, and enjoy the rest of the day.